Okay. Variables, expressions, and statements. Right, so we have in Python, before we talk about variables, we'll talk about constants. Constants are fixed values, such as numbers, letters, and strings, and that because their value doesn't change, right? So the character, what was it using here? It's not. The character X is always, and that was a really bad example, the number 1 is always the number 1, it's a constant. So numeric constants, as you expect, string constants use single quotes or double quotes. So that is essentially saying, it is telling you that you can recognize a string because it will have quote marks around it. And it can be single or double in Python, which is amazingly, so little things like this that make me love Python, because you can use either, it doesn't matter, as long as whatever you start with, you must end with. But the good thing about that means that if you want to, for example, want to have a double quotes or single quotes in the actual string that you're printing, and if I wanted to go, Right, so I've used a single quote mark there. Right, that's fine. I couldn't start with a single on each of those, it'd have to be a double. But I can't think of any other language I've ever coded in that is that good. You end up having to do all sorts of weird things. Well done, Carl. Like, anyway, it's a really, really, really big deal for me that you can do that. So every now and then that I just suddenly stop talking, it's usually because I'm coughing. So has today's lesson already been recorded? I'm recording it at the moment. So yes. Reserved words. So Python has a bunch of reserved words. It's because they are all used. Things like true and false, if, there'll be while, for, all these things are actually part of the Python code. The reason we're telling you this is because you can't use them as variable names, which we're getting to in a bit. So yes, none of these, it said you can't use them as variable names. So a variable is a named, a variable is a named place in the memory where a programmer can store data and later retrieve the data using the variable name. It sounds harder than it is. You don't have to know that it's a place in memory where you put it. It just is a variable. Programmers get to choose the name, and you can change the contents of a variable. So hence why it's called a variable. Variables are the absolute foundation of any computer program. So basically, one of the good things about learning is it's relatively easy to read and understand what's going on. But it fundamentally does all the main things that all computer languages do: variables, loops, conditions. So variables are if you can't get your head around variables, then you're going to be in a lot of trouble. So it's like a bucket, and at this point in time, in the X bucket, we're putting 12.2, and in the Y bucket, we're putting 14. And there we go, we've got a nice blue bucket over here. but because it's variable, we can, as we've done here, we originally put 12.2 in this bucket, and now we've thrown that in the bin, so we've got the cross, and we've put 100 in there. So now in the variable x, it has 100 instead of 12.2. This is fun, and I've already told my networking class, so I'll just tell you guys as well, and Carl will also back me up on this, even though it probably annoys him. I'm incredibly obsessive and pedantic about certain things, whether they're right or wrong. They're just things that annoy me. And one of the things that annoys me immensely is people not naming their variables. I was going to say correctly, but that's not true. Adequately, meaningfully. Can't stand it, especially if it happens to be somebody else's code that I need to maintain. So the rules around naming Python variables: it must start with a letter or an underscore, right? It must start with one of those. It can only have letters, numbers, or underscores. Can't have any other characters outside of alphanumeric except an underscore. And it can't start with a number. And they are case sensitive. All right, so this, when it says good, isn't actually saying it's a good name for a variable. It's just telling you that it's valid. So these are all alphanumerics, except for this one starts with an underscore, all good. These are invalid. You can't start with numbers. You can't have a hash mark in there because it's not an alphanumeric or an underscore. You can't have a decimal point. It's the same. These, very important. So it said it was case sensitive. So all lowercase spam, capitalized spam, or all capital spam, all capital letters spam, are all different variables. Now this is where I start twitching. If someone was to do that in a piece of code, I would not consider it very good coding. In fact, I can't see any real reason. I'm sure I've probably done it myself, or there is a very good reason, but I can't think of one where you would name two variables in the same script with the same name, but just with different capitalization. And I will say this as well, because I just actually just said it to my daytime class. There is lots of ways of writing code that solves a problem. If your code works, then that's satisfactory within reason. If you've used bad practices and it works, that's fine. If I have time, I'll usually give you a bit of feedback and just tell you what might have been more efficient. And is there a spell check? Why? It would just freak you out if there was, because there's so much stuff written in there that's not going to be adequate. Well, there's not going to be English, essentially. Especially, often you're honestly, I can't think of anything that has a spell check. Mass change, I'm pretty sure there's a find and replace. Yeah, no, that's fair call. So depending on what IDE you use, it will not be happy if you try to use a keyword as a variable. It will, well, Visual Studio will put a squiggly line under it, like a spelling error in Word. And any one of them will actually change color. So even idle, it will change color if you're using a keyword. So I might as well show you that quickly. So if I want a keyword like while, and I type while, it goes orange. True is also a keyword, so it's also orange. Now, print is a function, so it goes purple, and so this is all an idle. It's usually different in things, and green is text or a string, so everything changes, so it's pretty clear. Well, I hope it's fairly clear. Oh, and that reminds me, Cole, I may as well talk about the apparently new feature in idle. It doesn't allow you to break an infinite loop with Control-C anymore. So if I was to run that now, it would just print X forever.
We found that out the hard way last week.
Yes.
Actually. It was a surprise to me.
That's right. Yep. Yeah. Okay. So yes, good ways and bad ways. I don't consider using the same word with different case a good way. But if you do that and everything works, then that's fine. There will be lots of things that I will say this is how you should do it. But I will probably, it's unlikely I'll actually bring in any of my code to show you. Actually, I will, just to show you what bad looks like, and in some cases what good looks like. So yes, I'll say what you should do, but that's not necessarily what I do. Mnemonic variable names. So we're given a choice in how we choose our variable names, so there's a bit of best practice. You should name a variable that helps you just by reading your code to know what it's for, what it is you're storing in there. Unfortunately, that can be confusing to new users, because if you give actually I'll show you an even better one. If you give a variable a really good looking or whatever name, people can start thinking, well, is that a is that actually a function or a reserved word or something? For example, here's a great example. So we have this function called, this is just notepads, this won't do anything. We have this function called print, all right? So I can put anything in there. Yep, all right. And then I can say print equals 1 and print equals 2 and input equals print plus print. Print input. Anybody know what would happen if I wrote that code and pressed return? It would indeed. All right. Hopefully most people there can see why that would be a stupid idea. I shouldn't say that in case somebody's actually ever done it. But that's perfectly okay in Python. That's the function, but any of these are variables because they have different case. So everything's different. So don't use words like print as a variable name, and certainly don't or try not to make something that sounds particularly function-like. Right, here's a great example of some terrible names, and hopefully that's pretty clear. Obfuscation. Do you know, the only time I hear that word name, generally speaking, is in my forensics class. So I don't know what it is you're trying to obfuscate, but hopefully it's yes, or yes. So yes, these are terrible, terrible, terrible names. And as I say, given being someone who actually has to open other people's code and either maintain it or debug it, I would be livid if someone did that. But it happens. Some people do it because they think it's clever, because they know that it's going to annoy the next person. But anyway, pretty hard to tell what that's doing, right? Right, so this is the same, but using A, B, C, A times B, print C. It's exactly the same piece of code. However, and get ready, Carl, because I'm about to give you a lead into your joke, so be ready on the keyboard. It's terrible practice in general to use a single letter as a variable, and it's certainly not considered good practice, except for some reason, an iteration variable, which we'll get to later, it's commonly accepted to have the letter I signify an iteration variable. Oh, come on. Too slow, mate. I'm going to move on. There we go. All right, so, and again, I've been known to do this. It's quick and easy. Just drop down a letter very quickly. Yeah, it is called primarily because it's always, for some reason, uses iteration variable, which, yeah. Look, your reason or joke is just as likely as any other reason. So yes, again, not good practice. No one's got any trouble for using it. Makes it very difficult again to maintain or debug someone's code. Not explanatory, right? So here is something that's potentially a bit better. So we know that in this case, hours 35, rate 12.50, pay equals hours times rate, print pay. That is a lot better, obviously, than this and this. But just to be annoying, I'll make that again. No wonder you need a pay rise. Yeah. And this is exactly what I would do. I'll do it properly. That would be my first one, but in actual fact, it would be. But we know we don't do that in Python. Hours per week, hourly rate, and weekly pay. All right, that's how I would write those same ones. I sometimes will write variable names that are almost like a complete sentence. But that's primarily because these days I didn't do that when I was first started out, because there wasn't fancy things around like Visual Studio or PyCharm, that if you've declared a variable somewhere and then you start typing it somewhere else, it just pops up and you just press enter and it appears. So it's okay to write really long variable names, but it wasn't before. This bit, yeah, I can do that. Size equals Is that better? Yeah. So again, it's just another one of my little obsessions, I guess, but it's really, really bad, I can tell you, when you've written some code and it's been out there for a while, you haven't had to look at it for a bit, and then someone reports a bug, and then you get your own code back and you can't work out what it does. And it's usually for one of two reasons, or potentially both, because you didn't put lovely names like this for your variables, or you did not comment it adequately. And we'll certainly get on to comment. We touched on commenting last week, but it will be very important later. Okay. All right. Sorry. Better to comment than not. Totally. Absolutely. So long as there's not more commenting than code, that's probably a little bit over the top. But assignments. So we'll see here. What have we got? Orange is a variable. Anything that's white is an operator. Anything that's blue is a constant, like the number 2 in this case, and yellow is a function, like print. So x equals 2 means that we are assigning the integer 2 to the variable x, which makes it an integer variable. If we want to assign something with an expression, in this case x plus 2, so x now becomes 4, so it was 2, we've added 2 to it, so it's now 4. And one of the other things that bugs me about just little things, about things like that, is that's extremely bad practice, but it's probably a little bit early on to show you how to write it correctly, but just annoys me. Anyway, then our print statement, which we're going to print out our variable, which in this case will print out the number 4. We assign a value to a variable using assignment statement. All right, so the single equals means we're assigning something to the variable. And this one here is showing us that it's an expression. So expression on the right-hand side of the equal sign, variable on the left-hand side, and the assignment operator in the middle. And I'm not so sure that we need to teach you how to do mathematical priority, but essentially that gets whatever its answer may be, and it's assigned to the value, to the integer, to the variable x. All right, so what was it saying? A variable in memory location used to store, okay, so it was 0.06, and now it's 0.936 because of this wonderful expression. I don't know why that's any more descriptive than just saying that 1 plus 2 equals 3, and then that's what gets assigned. But if you want to go and have a look at these slides, knock yourselves out. All right, expressions. So most of you will be familiar with these. Addition, subtraction, multiplication, division to the power of, and remainder. So the addition and subtraction are what we would have always used as standard operators. When we got into computers and coding, they don't have a multiplication symbol or a typical one. They use an asterisk, or the typical division sign, they use the /. And to raise something or to the power of, or an exponential, in Python uses 2 asterisks, and the remainder uses the % sign, which is also called the modulo or modulus. And I think we talk a little bit more about that next week. It's going to tell me. What's this going to tell me? Again with these crazy variable names. So I'm starting to twitch now. So yeah, these are all pretty straightforward. X equals 2, X plus 2 equals 4. So we're going to print 4. Again, we made it with an expression. So 440 multiplied by 12 is that. And this is an interesting one to remember. So y is equal to 5. It's not going to make any difference, is it? Y is 5,280 divided by 1,000 gives us 5.28, which it does. But any result from a division in Python always is a floating point number. So just to show you that, if I do 10 divided by 5, it gives us a floating point number. It doesn't matter whether it's actually an integer, which essentially 2 is an integer, it will return it as a float. What else have we got here? J equals 23, K equals, okay, so we should probably go through these with something a little bit better, I think's better. So here we're using the modulo sign, the percent, to get a remainder, which is essentially what it does, I suppose. So if I was to do 10 divided by 4, I get 2.5. If I was to do 10 modulo 4, I get 2. So 4 goes into 10 twice with 2 left over, which is what that's telling me there. So if I was to do 10 modulo 3, it tells me that 3 goes into 10 3 times with 1 over. So that's what that does. Should I do that? No, I think we'll do it next week anyway. So that's what the what it calls the remainder there, but it's actually called modulo. And then the exponential. So I think most people know what 2 to the power of 2 is. All right. Okay, so that's how you do exponents in Python. Okay, order of evaluation, again, most people would have learnt this at school. When we string operators together, Python must know which one to do first. Operator precedence, which I cannot remember. It's not what I called it at school, but it's because I'm old. Young folk call it something. Is it somebody? Yes, not quite, I don't think. Something like that. Certainly something like that, but I don't think that's it. That's it. BIMDAS. That's the one I've seen. So yes, it just tells you how to brackets of division and multiplication. Okay. Oh dear, gone down a rabbit hole. So yes, operator precedence. It just lets you know, and it's no different to normal mathematical precedence. So what do we do first? We do the exponents, and then we do the, well done, Carl. That's awesome, Carl, because everything in Wikipedia is absolutely 100% factual. So yes, it's no different to normal mathematics. The precedence is the same. All right, the rules. parentheses are always respected. So if we go back here, 1 plus 2 is essentially, well, not essentially, it is the last thing that you would do. So it wouldn't be 1 plus 2, it'd be 1 plus whatever all this was. But if I was to put parentheses or brackets around the 1 plus 2, that is the thing that we would do first. All right, so parentheses are always respected. Then exponents, multiplication, division, and modulus or remainder. Then addition and subtraction, and we go from left to right if we've got competing precedents. Okay. Let's give you an example. So we do the exponential first. So that's 2 to the power of 3 is 8, which is there. We do the 8 divided by 4, which is 2. Then we do the 2 times 5, which is 10. And we add 1 to it, which is 11. Operator precedents, remember the rules top to bottom. So these here are when writing code, use parentheses. When writing code, keep mathematical expressions simple enough that they are easy to understand. So I should have, just let me see if I can find a tiny piece of code that I wrote for a Python class. If you think that's good, you get to learn Boolean algebra next week, unless you know that inside out. Where am I going to find that? That's right, Dane. Logic gates and stuff. Sorry, I might not be able to find this piece of code just to, it's a really good example of how not to code something. Oh, come on. No, I'm not going to be able to find it. Sorry about that. But essentially, if you're writing some if you're writing some complex expressions, you should bust them up into different variables that have a meaning, and it's a much better way to certainly be able to maintain or debug some code. Oh, sorry, I'm still searching for it. Unfortunately, I am shocking at arranging my files. Oh, hang on, they might be here. Well, we've already established, Carl, that you're never wrong. So No, I'm giving up. So yes, if there's something that you are that involves a very big calculation in the code, which is not uncommon, break it up into meaningful variable names so that it's easier to debug if necessary. Simple enough. Yep. Break long series and make them more clear. What does type mean? Type tells, so we have all sorts of different types of variables. How can we fix a variable to a specific type? Why would you want to? And I'm sure there's lots of reasons, but I can't think of one at the moment. I know how to do it in other languages actually, but I usually avoid doing that. For error checking for input. Okay. I guess you could, if you wanted to force something to be an integer, for example, every time you reference it, you could just do that. But anyway, all right, so type. So it's a function in Python that will let us know what type of variable a variable is at any time in the code. So we have different types of variables. I think we've covered off, for the moment, we've covered off integers, strings, and floats. That's all we've talked about. We just spoke about booleans earlier. There's actually many different types. There's dates, and others I can't think of. Oh God, I don't even know how they. Every language generally has a short number, which I'm pretty sure in Python is integer, and so that's any number up until about 65,000 or thereabouts. And if you want a bigger number than that, at least in other languages that I've used, it is called a long, and that's any number at all. And the whole point of that is when you Python 2, they're probably in Python there. I just never used them. And the whole point of that is that as soon as you create a variable, you've reserved some space in memory. So you use the smaller number that you can, if it's adequate, rather than using the one that can have as big a number as you like. Anyway, so type Python. So we'll do that. All right, so x equals 1. So what type of variable is that?
Greg, are you sharing your screen?
Sorry, who was that, and what was it you were asking about?
Greg, Shikal here. I'm just asking, I can't see your screen. Are you sharing your screen?
I am. Anybody else? Can everybody else see it? No? Yes? Okay. Looks like it. Yes. I am sharing my screen and everybody can see it except for you. Okay. So yep, that shows that our variable type is an integer. If we did something else, I don't know. See my terrible names for my variables. And that will be a string. Oh, what did I do? I did type X again. God. All right, so that's a string. You can do that with anything. You can ask a variable at any point in time what type of variable it is. I'm not sure what question, what slide example, and what hello there print. Okay. Python knows the difference. For example, plus means addition. If there's two numbers, if there isn't two numbers, or if there's two strings, it will add them together. Sorry, it will concatenate them. So you can see here, we've got hello plus there, and that will just push the two together. And you can also see that there's a space between them, and that's because there's a space in here. If you didn't do that, it would have been a single word. Here we go. So it knows what type. Some operations are prohibited, so you can't add one to a string. So up here you'll see it's tried to grab a string, which is hello there, and then add it to one. One's an integer, so it doesn't know what to do. Are you asking me to concatenate? Are you asking me to add one? It doesn't know. So it throws an exception. Now, the error codes in Python, well, I think they are particularly good because they give you all sorts of great information. Should be enough information that a lot of the time it will be enough to help you find a bug in your code. So you see in this, it says, so you start at the bottom usually. Can't convert int object to string implicitly. All right, so it's basically saying that that can't be converted to a string in this instance. We can convert it to a string, but not in this line here. And so it tells you what sort of error. This is a type error. This is something you will need to know for a lab not too long in the distant future. But one of the best things it does is it tells you what line, and we're in the interpreter, it's always line 1 most of the time. It'll tell you what line in your code the error was caused, which is fantastic. Right. Okay, several types of numbers. Two main ones, integers, as we said before, and more than 64,000, and floating point numbers. There are other types of numbers, variations on float and integer. All right, so I didn't do that one actually, just for completeness. It is a float. Type conversions. So this is when we change a variable type to something else, which I'm not sure. I've always known it as casting, to the point that cast is the command in some other programs. But changing the variable type is possible in Python, so long as you're not trying to change it to something it cannot be. So you can't change the letter X to an integer, for example. That will throw an exception. So you put an integer and a floating point in an expression. The integer is implicitly converted to a float. But you can control this with built-in functions, int and float. You see here that this float command here, float function, will force the number 99 to be 99.0. So we add that to 100, you get 199.0. What's the next one? Do I equals 42, we do a type, it'll tell us it's an integer. F equals float I, so F is now equal to 42.0. So we print it out and there it is. And F, type of F is float. All right. Sorry, I just had another coughing fit. Right, integer division, which I touched on before, just letting you know that any division always results in a floating point number or a float. So 10 divided by 2 comes out in 5.0. 9 divided by 2 would always be 4.5. 99 over 100 would be 0.99. Dividing two floating points comes out in a floating point. Dividing anything comes up in a float. It's different in Python 2. There was lots of things that were different in Python 2. And as I was banging on about please don't use ChatGPT because it is not infallible, that was one of the things it did, which I was quite fascinated about, is one student submitted what clearly came out of ChatGPT, and it was Python 2 code, which a lot of that doesn't work anymore. Does it, Carl? You got used to putting your brackets around your prints yet? Yes, sadly, okay. Is Python 2 older? Generally, anything is older that is a version beforehand. From future import print statement. Okay. .311. It did say on the shell when I was 3.11.4. There you go. Well past Python 2 anyway. String conversions. So we can convert strings, like characters, into an integer or float. But there are certain rules around that. Hopefully most of you understand that you can't convert a string that says hello world, which is a usual string we use in computing. You cannot convert that into an integer or float. It will do this. What are we trying to do here? It's our type, it's a string. We're not even trying to convert anything yet. So that was what we did before. You can't try and add an integer to a string. You'll get this. ival, what's ival equal to? Oh, okay. So sval is equal to 123 as a string, and now we're forcing it to be an integer. I was quite happy to do that because this string 123 can actually be an integer 123. And then we can print. Then we can do mathematical operations on it. NSV equals hello Bob. Yeah, here we go. So we've tried to force NSV, which is the string hello Bob, to become an integer, and it says to us value error. Remember our last one was type error. This one's a value error. Invalid literal for int with base 10, etc. So the literal is that, and it's invalid for the int function. And of course, as I said before, it tells us that it happened on line 1. All right, we can instruct Python to pause and read data from the user using the input function. The input function returns a string, always returns a string. We can obviously, we can convert it to something else, but the input function will always return a string. Can anybody in chat, obviously, tell me why that's a really useful, call it a feature, a really useful way that Python works, that an input always returns a string? Nobody? Okay. Because anything can be a string. So the number 10 can be a string, the number 3.0 can be a string, the word true can be a string, anything can be a string. So you can guarantee that your input function will not crash because somebody's put something in that they shouldn't have. So here we've got the input, who are you? Now, a couple of important things here. There's a space after the question mark. If there wasn't, you can see the output here would be right up against the question mark. So make sure that you control the output of any code that you write. That's incredibly important. And then it prints out whatever you put into that that variable. Sorry, just hang on a sec. Okay, my apologies. But Carl just reminded me that there's going to be a big blank spot in the recording this week because I didn't turn the recording off. Well, that's okay. Actually, that's a good point. So since Carl and I are in completely separate classrooms, usually when we're here, and very few students turn up, so we tend to congregate in the same room. So if you are one of my students, you would have a on your timetable room A106, and we generally would all go into the other room where Carl is in A143. So that's a reasonable question that has two answers. Yes, you can do that in Python, that you can assign variables that way, but it is not considered very good practice. But it works. All right. So that's input, right? So that's all good. Input will always return a string. I'll stress that a couple of times because you might get asked that at some stage. All right. So we know that whatever we get back from an input is always a string, and we can't add a string to a number. So what if we're asking, what if we want an integer? So we want to read a number, we must convert it from a string to a number using a type conversion. Later we'll deal with bad input data. So next week I think we talk about handling errors. And this is the most, I don't like this example, to say the least. I think sometimes people have gone out the way here to make things harder. So that's no good. So right down the bottom. Question mark and space. And close. Sorry, you can't actually see the rest of that. But that's my question. And you can see this is blinking. And actually, that was another thing I wanted to bring up before we started. There's quite a few people who were using the input statement in Lab 1. And after they got here, they didn't know what to do. So when you get to this point, you need to enter something. At least press, well, so a lot of people just pressed enter, which means that your variable, which in this case is classroom, will be empty if you just press enter. But instead, we will enter the classroom, which is in the A block, and it's class number 143. So A143. Okay, so if I now ask classroom what type of variable is, it's a string. Now, so for some strange reason, I want to add, I want to add an integer to that value. I would have to convert the string classroom into an integer, because 143 at the moment is a string. So I can say, I won't do that. I could do that. No, that might be too confusing. Oh, I nearly did camel case. Integer conversion equals int classroom. All right, so sorry, I'm going to be painful. I'm going to do what I was originally going to do. All right, so now I'm forcing the variable classroom to become an integer. At the the moment it's a string, and hopefully now if I do type, it is an integer. So as I said, everything that comes in as a result of an input is always a string. Sometimes we will want an integer or a boolean or a float, and we can force it over with whatever the function is. So it's int for an integer, it is FLT, I think, for float, and BOOL for a boolean. Can the variable be in two data states, or is it always? No, it's always converted. Always converted. Okay. Oops. Commenting. There you go. We got to commenting. Anything after the hash mark is ignored by Python. Completely, right? So it's like a blank line, which is also ignored by Python. So why would we comment? We would describe. Will only. Right, Ben. Absolutely, you can do that. No problem at all. But what happens if someone enters X? Well, there's several. I'm pretty sure that well, in fact, I'm absolutely sure that concept comes up in this lab or the next one, doing exactly that. So forcing the input from a string to whatever else at the time of capturing it. It's probably not the best thing to do because you've left yourself open to things going wrong. And if it's a very, yes, you can do it. Short answer, yes, that's completely possible, and you will actually be shown how to do that. So why are we commenting? Describe what is going on, what is going to happen in a sequence of code. Document who wrote the code or other ancillary information. Turn off a line of code, perhaps temporarily. Oh, I need to bring in some of my own code. So you'll see, and eventually I get around to cleaning it up, but you'll see in a lot of my code, tens, if not hundreds of lines of code that are commented out. So while I'm going through writing stuff, I'll try something and it kind of does what I want, but not exactly. So I'll comment it out because I don't want to lose it, because maybe I can just improve on it. So I'll comment it out so it's not read by the interpreter and try something else or whatever. And I end up with blocks of code that are commented out. So eventually I'll go back and clean it up. But it is certainly a very good use for commenting. The most useful reason for commenting is to describe what's going on. Now I'm going to expose myself, I'm sure, here if I go and try and open a piece of code that I've written, because it'll probably be poorly commented. It's meant to make code more readable. At some stage in the very near future, we're going to come across a concept called pseudocode, which some of you may have already come across. Now, if you write your pseudocode really well, it becomes the basis of your comments, which is probably more information than you need right now. So I'm not sure whether this is going to be good or not, but we'll put it up there. And can I, oh, it's really hard to change the font size on in VS. Hopefully you can see that a bit. So these are the comments. So my commenting here is just describing, for example, this is a function. So that's just telling you what this function does. And there you go. Windows key. Okay. How do you know how to do stuff in Windows? What are you trying to do to me? Dude.
Windows key minus to go back, yeah.
Why did it go so enormous? Let's try again. But you didn't answer my question about how you knew how to do that. Oh, Jesus. I've apparently got the choice of 100% or 200%. Man. Why don't we have Linux desktops here, Carl? Wow. So what I was trying to do was just change the size of the font. The only choice I have is to change the entire size of the screen. Yeah, it's not doing anything. All that does is scroll. Bugger. Have to revert to a lesser. Okay. Is that a bit better? Is it actually legible? All right, so anything that is grey in Sonny is a comment. So that comment is just describing what this does. That one is describing what this does, but you'll see here, I've just commented this single line, which is quite normal. So when you're commenting, you would normally be expecting either yourself or someone else that knows what's going on, I guess, to be looking at it. So that would be meaningful to them. But then potentially this bit wouldn't. So you're just commenting that one line. So you can see it's on the same line, but anything after the hash is completely ignored. Print, converts, prompt. And this is reasonable commenting. I wouldn't say it's my best work. I'm going to make a comment on my commenting, Carl. Oh, ooh, it's getting a bit light on now. And here we go. Here's a line of code that I've commented out. So that's actually code. And I've commented it out for one reason or another, B+. So that, as it said in the slides, you might just comment out a line of code, maybe never put it back. And for whatever reason, I decided not to put that one back. But certainly, wow. Wow, that's really bad. That wouldn't be satisfactory if you submitted that. Right, so there you go. describing what's happening, and it's also very good, as I said, to do it, excuse me, to do it on a particular line if it's, well, comment worthy, something particularly different. And the other who wrote the code, which you guys are obliged to do when you submit some code, should have your name and student number and a version, and turn off a line, which I had done in that piece. All right, so this is essentially the same thing, saying this is what this bit of code does, and then this is what this block does, and etc. And somebody should be able to go, okay, it counts the word frequency, look at that and work out how it does it. And that's it. So we went through types, reserved words, variables, operators, operator precedence, integer division, conversion between types, user input, and comments. Anybody have any questions particular to tonight's presentation? What those commands with here, is that for example? Yep, so you will learn all about these. Anything that, I won't go too much into it, but anything that has a dot and then something like that after it, this bit is called, excuse me, a method, and different types of variables have different methods that allow you to do all sorts of wonderful things with them. And we will most definitely be covering those. In fact, that particular method we will be talking quite a bit about. Yeah, that was the Queen Jack split. Yep. Yes, I will. I was planning on doing that. Do I still record that, Carl? Working through the, going through the...
Yeah, maybe just make a separate recording.
Oh, okay. Well, then I'll stop this one, unless anybody else has any questions, and we'll go through the... we end up with a number. Wow. Each time we end up with a number as a result of an operation, we need to convert the 3 to an integer for the next operation. I obviously did not do my job tonight, because the short answer to that is no. So we are able to add integers with integers, right? And so if I go x, I try and go x, and this is giving me a hard time for some reason, because I'm on the wrong line, x equals 1. So x is an integer. It will always be an integer unless we either convert it to be a string, which we can do, or we completely change it, which is something you can do with Python and other languages. That's called dynamic typing. So if I wanted to say x is now equal to any sort of text, I've changed x from an integer to a string on the fly. A lot of programs won't let you do that. Python does. But back to where I started. So I go x is equal to 1. It's an integer. It is an integer variable containing 1. If you want to do any mathematical operations on that, not a problem, because it's an integer. You don't need to change anything. You only need to use a conversion if the variable isn't of the type that you want at the time. So if we do a type on x, it will tell us it's an integer. if I make y 2 with quote marks around it, it is a string. All right, so that's now a string because it's the character 2, not the integer 2. Now, when you would want to force something or convert something over, is in this case, if we wanted to come out with the response of which yours was 1 plus 2, we can't add 1, the integer, to 2, the string. It doesn't make any sense. So we would need to convert y to an integer first. So y equals int y. Now if we do type y, it's an integer. See, it was a string here. We forced it over to be an integer. So now we can do z equals x plus y. So z equals 3. And now y is an integer variable, and it will be unless some point in the code it gets forcibly changed over, whether via conversion or, as I said, dynamically allocating another value to it. So yes, actually I didn't quite answer your question. So now we've added 2 integers together. Our result is an integer. We don't need to do anything to make that an integer. It is one. Any other questions? All right, I will turn off the recording. Oh, hang on, here we go. If I type x equals 1, then x equals x plus x. Output is 2. But shouldn't variable value change? So x is equal to 1. So if you add 1 to 1, you get 2. But shouldn't variable value change? Oh, I'm missing. So let me see if I'm understanding you right. So we're saying first up, x equals 1. Yep, we're good so far. And then you want x to be equal to x plus x, which is exactly the same as saying x is equal to 1 plus 1, because that's the value of x, right? So x equals 1 plus 1, so x is equal to 2. That shouldn't variable value change. X again for x plus x. It doesn't change until it's assigned another value. You haven't, your x plus x is not an assignment, it's an operation. The assignment is x equals. So your operation is 1 plus 1. And then you assign the result of that operation to your variable. Okay.